you need to use the lecture notes to do these questions, all 4 questions. If you don't have a copy of the notes, I can give you one. I've got only one spare copy. Anyone? You just need to figure out the rejection rule for the given hypothesis. You're doing question 1, so question 1. Yes, Alright guys, okay, I know some of you have already done this question. So let's look at question 1 guys, which is to find the power function for this hypothesis. Now, as you know, the power function is defined as the probability of rejecting the null hypothesis given theta. So what you need to figure out is the rule for rejecting the null hypothesis corresponding to this. Now, if you guys look at the lecture notes, you will see the rule for this is do you see this guys? Yes or no? Do you see where this comes from? This comes from page 21. I think it's on page, you should look at page, if you look at page 21 of the notes, you will see this rule for rejecting null hypothesis. Right? It corresponds to the set of hypotheses that theta equal to theta 0 versus theta less than theta 0. Right, now to simplify this guys, you must realize that we are conditioning on the fact that the true population mean is theta, not theta 0. So the first thing you should do is to replace theta 0 by theta. So you need to add a theta. Yeah. And the next thing to do is to take these two guys here to the right hand side. So that will give you the probability that root of n right. Now the next thing you must realize guys is that conditional on the true population mean being theta, this has the standard normal distribution. Do you see why? Because of, I mean, this is the result I proved in week 1. You probably remember this. If you don't remember this, just please, if you don't remember this, this is a result I proved in the first week of this course, right? So using this fact, you must be able to see that this has the standard normal distribution, right? So what you have is the probability that n01 variable is less than now you will see the conditioning disappears here because the conditioning that the true population mean is theta has been used to argue that this has a standard normal, and therefore we don't need it anymore. So at this step we don't need the conditioning. Okay, so this becomes phi or phi alright. So this is the power function. This is the power function for question 1. Is it clear to all? Yeah? Are you guys okay? Anyone not clear, guys? Question, alright, if this is clear, question 2 is very similar to question 1, so I may just as well do it now, because the only difference in question 2 is just the rule. In this case, the rejection rule is simply pretty much the same as this one. The only difference is that you have greater than sign, not less than, right? So you will see this if you look at page. If you look at page 20 of the lecture notes, you will see that this is the rule for rejecting the null hypothesis. Yeah. And now you simplify this in the same fashion as question 1. So the first step is to replace theta 0 by theta. Then take these two terms to the right hand side. Okay, so this becomes and then argue that by the same reasoning as over here, this must have the standard normal distribution, and therefore this guy here is the probability that a standard normal variable is greater than okay, and this you can write as 1 minus phi or phi okay. So this is the answer to question 2, guys. Is this clear to all of you guys or not? Yes. Yes, sir. Oh, sorry, yeah, I made a mistake. Oh, how come? Sorry, over. Sorry, guys, you should have mentioned this to me. This should be that's the I apologize for the mistake. Yeah, it should be theta minus theta 0. I think that the bottom one is correct, I think. Alright. Thank you for pointing this out. I appreciate it. Okay. Can you guys do question 3, please, now? Please. That's okay. Alright guys, let's see how we can do question 3 and 4. It's similar, I mean, so question 3, sheet 9. I know some of you have already done this, but let's see anyway. The power function is a function of p. P is the proportion. Now, once again, if you look at the hypothesis, guys, the hypothesis we are looking at is p equal to p0 versus this. So once again, if you look at the rejection rule in the lecture notes, it is as follows. This is the rule in the printed lecture notes, although I gave an alternative set of rules which are slightly different from this. So you can use either one of them, but I prefer to use the one in the printed notes. This is the version in the printed notes. Yeah, you remember the other day that I gave you alternative set of rules where you replace x bar by p0, but sorry, x bar by p, I think, or something like that. But you could I would prefer to use this one anyway. Right. So the first thing you must do, as before with question 1 and 2, you must realize that we are conditioning on the fact that the true population proportion is p, and which is not the same as p0. So the first thing you must do is it's the same as what I've done before. That is, replace p0 by p. Yeah. Then take these two guys to the right hand side. So you get x bar minus p less than minus z alpha minus okay. Now I'm going to make the following approximate. I think I mentioned this result before in the lectures. This means approximately distributed as. I'm going to make the assumption that x bar has the approximate normal distribution with mean equal to this and variance equal to this. Now, under this approximate assumption, you will be able to see that this guy here has the standard normal distribution, right? So the next step will be an approximation, right? Because this is approximate, this must be approximate too. So this is approximately equal to the probability that a standard normal variable is less than once again, I have the conditioning is no longer needed because the conditioning has been used to argue that this has the standard normal, and therefore it's no longer needed, right? So finally, this would be phi or phi Alright, so this is the approximate power function for question number 3. Alright, and question number 4 is very similar to question 3. The only difference is that the sign changes. So pi of p will be the probability that so instead of less than, you have greater than. Okay, so the sign changes to being greater than. So the next step is as the same as before. Because the true proportion is p and it's not p0, you replace p0 by p. Okay, and then you take the as before, you take this to the right hand side. Right, and condition on the true value of p. This, as I said before, this will have an approximate. Standard number distribution. So the next step is an approximation. Once again, the conditioning has disappeared. Now finally, if you prefer, you can leave it like this, but if you prefer, you can rewrite this as 1 minus phi of phi at okay. Alright guys, so this is question 4. Now the reason I have finished run through them quickly because by the way, any questions on this, guys? Is that okay? The reason I have run through them quickly is because you may remember, can I take this wait for a while? You may remember last week we did this was a sheet that we did last week. You probably remember, and we did not complete this last week. We only did question 1 to 4, and we did not do question 5 or question 6. So what I'm going to do today is to do. Do you have a copy of this? You guys have a copy of. This is sheet number 5, guys. Sheet 5 we did last week. Sheet 5. We did not do question 5 or question 6 last week. Alright? So I want to do them now. Okay? Unless you have questions on this stuff I did. Alright, so anyway, let me show you. If you don't have a sheet with you, these are the questions, guys, if you want to see. So I want to do, this is question 5 and question 6. Alright. So I will do question 5 in a minute. Give me a sec. Right. The question 5 says the following. It says, so this is question 5 from sheet 5. Okay. Basically, you have the following. You have x1, x2, xn, iid from a normal distribution with parameters mu and variance 20, and we are testing we are testing mu equal to 100 versus mu less than 100. And we are told that alpha is the type 1 error, is equal to 0.05. And the question was to find the probability that you reject the null hypothesis when the true value of mu is 95 is at least 0.9. So, sorry, the question was to find the n is the sample size. The question was to find n such that the probability that you reject the null hypothesis when the true value of mu is 95 is at least 0.9. Right? Do you remember the question, right? Yeah. So how do we do this, guys? How do we do this, guys? First of all, you need to find the rule for rejecting. We have mu equal to 100 versus mu less than 100. So the rule is what? The rule is root of n divided by sigma, which is root of 20, times x bar minus mu 0, which is 100, less than. Yeah, this is the rule. Given that mu equal to 95, and we want this to be greater than or equal to 0.9. I mean, you guys know where this comes from, right? This comes from page 21 in the lecture notes. Page 21, okay? So to deal with this, you must realize that the true population mean is 95, not 100. So the next thing you must do is to change the 100 to a 95. Alright? So you need to add a 95 and subtract the 100. Yes? Now group these together, take them to the right hand side, right? 95 minus 100 is minus 5. Take them to the right hand side, it becomes plus 5. Okay, so it becomes yeah. You guys with me? Now what can you say about this, guys? Condition on the true value of mu being 95, this must have the standard normal distribution, right? Okay, so this is the probability that NO1 is greater than, oh, how do it become greater than, guys? You should, man, I don't know why. It's less than, guys, less than, okay, sorry about this. So less than, there's no greater than here. Okay. Yeah. Yes. Are you with me so far? Yeah. All right. The next step is to. This is the phi or phi at minus. Now, what we need, I mean, the question, now just pause for a moment and see, the question was to find the value for n is the sample size. So we need to solve this inequality for n. So the next step you must do is to get rid of this function phi. Now, how do you get rid of it? How can you get rid of this? Is to take the inverse function. You should multiply it by the inverse function of this, left and right. You get you see what I've done? I have taken the inverse function, multiplied both sides of the inequality by the inverse of phi or phi, right? You get this, right? So this becomes this. Then root of n becomes greater than root of 20 divided by 5. Yeah. And now finally you should square this. You should square both sides. Then n will become greater than or equal to 20 divided by 25 of square, right? So that's the answer. So so the answer to the question was to find the probability that you reject a null hypothesis when mu is 95 to be at least 0.9. So find n, and the answer is that the sample size must be at least equal to this. Obviously you should have a calculator, you can work it out. I don't have one. So if you have the table and the calculator, you will know what this number is. Yeah? Okay. Are you guys okay? Yeah. So that's question 5, one of the questions I didn't do last week. Now question 6. Oh, let's wait for a while. Question 6 is let me know once you're done, once you finish writing. All right. So the question 6 is this one, guys. If you don't remember, this is question 6 from last week. So let's see how we can do this, okay? So this is question 6. So you have the null hypothesis is sigma is 10 to the power minus 2 versus the alternative is that sigma is greater than 10 to the power minus 2. And you're told that alpha is 0.05 and you're told that n, the sum is 35, and the question was to find the probability of type type 2 error, right? Remember, type 2 error is what? Is the probability of accepting the null hypothesis when H1 is true, right? So this is the probability that you accept right? You can also write this as 1 minus the probability that you reject okay. Now in this particular question you are given the value for the true value for sigma, which is 2 times 10 to the power minus 2, right? 2 times 10 to the power minus 2 is satisfied by this, which is the alternative hypothesis. So what I'm going to do is I'm going to put the true value for sigma, which is this, right? And one more time, if you look at the lecture notes, for this hypothesis, right, you will see the rejection rule, which says the following. I can't remember the page number now, but if you look at this is the rule, if I remember correctly. This rule comes from the lecture notes, guys. If you look at the right page, you'll see that. Okay. Yes. Right. So this becomes 1 minus the probability. This is basically n minus 1 times s squared divided by sigma 0 squared greater than chi squared n minus 1 alpha, right? So this is 34 times s squared divided by 10 to the power minus 4 greater than chi squared 34.05. Right. Now one thing you must note here is that 10 to the power minus 4 is sigma 0 squared. It's not the true variance. The sigma is the standard deviation. So the variance is sigma squared. So if you square this, what you get is 4 times 10 to the power minus 4, which is not the same as this. So what you must do in the next step is to introduce the true variance. Which is 4 times 10 to the power minus 4 is the true variance, because sigma is equal to this. So because I divided by 4, I need to multiply by 4, right? Right, now in the next step, I'm going to take the 4 here to the right hand side. So this becomes yeah. Alright, now I've got a little question for you guys. What distribution does this have and why? This guy here, what distribution do you think it has and why?
Chi-squared?
Yeah, it's chi-squared with 34 degrees of freedom. Do you guys know which part of the notes it comes from? It comes from the fact that n minus 1 s squared divided by sigma squared. And sigma squared is the true variance, has the chi-squared distribution with n minus 1 degree of freedom. It's basically equation 72 on page, can you see this? Sorry. It's equation 72 on page 16 of the lecture notes, right? You probably remember the result, right? Yeah. I used this several times in the lectures too. Yeah, this result here, this. So this has a chi-squared with 34 degree of freedom. So this is 1/4 times. Now we don't need this conditioning anymore because we have used the conditioning to argue that this has a chi-squared. So the conditioning drops out, right? So this becomes the probability that less than or equal to 1/4 times yeah. So that's the. Is it clear, guys? So you alright? Yeah. Okay. Yeah. All right. So, these are all the questions on sheet 5 and sheet 9. Next, when you return after Easter, we will do sheet 8. Sheet 8. We will do sheet 8 on the week after Christmas. Week after. 6 is not examined. You can ignore it. have a good right. If you have any questions, guys, just send me an email or come and see me. Yeah. I don't mind. Have a good break. Have a good break. Have a good break, guys. This is the break. Yeah.